So yeah, Lepus is one of those constellations that I think a lot of us overlook, but there are some really cool things to check out in it. Most of us, when we go out and we're looking at that part of the sky, we stampede right towards Orion and usually overlook poor little Lepus there at the feet of Orion. And if you want to find Lepus at this time of the year, just go out around 8 or 9 p.m., face towards the southwest and look for Orion. And then right underneath them, if you have good dark skies, you should be able to see the stars that make the outline of Lepus, the hare. And Lepus is the Latin word for hare, by the way. So we'll look at Lepus here, just a little quick overview. It's not a very big constellation. It only occupies 290 square degrees upon the sky. In contrast, Orion is like over 590 square degrees on the sky. So Lepus is fairly small. It belongs to the Orion family of constellations, and that includes Canis Major, Canis Minor, Monoceros, and Orion himself. First cataloged by Ptolemy in the second century in his book, The Almagest. And it does contain a wide variety of really cool objects, deep sky objects. There's a lot of double and variable stars. There's a Messier object, a couple of galaxies, and even a planetary nebula, the Spirograph Nebula, if you're familiar with that. And I decided I was going to focus on just 3 objects within Lepus. And most of them are binocular objects. One is going to probably require, to see it at its best, a telescope. We'll get to that one in just a minute. And let's see, how do well, I was afraid of that. This thing has been acting up all day and it freezes up on me and then I can't share my slides. There we go. So let's talk a little bit about the mythology of Lepus. In fact, there's really not much in the way of mythology regarding the hare. But there is one story that comes to us from Hyginus, who was a poet back in the times of ancient Greece. And he tells us a story. This is kind of a moral fable. He tells us a story about a farmer from the island of Leros. And you can see it down there in the lower right-hand corner, marked in red. It's a little tiny speck in the middle of the Aegean Sea. And he had ventured to the mainland in Greece and he bought a rabbit. And he was going to take it back to Leros, where there were no rabbits. But he got a pregnant female. He takes it back and the female gives birth. And he's got more rabbits than he can handle. So he starts giving them out to his neighbors. And before long, they start breeding their rabbits. And the island is soon overrun with rabbits. And before you know it, it's eating them out of house and home. So the farmers all get together and they decide to run all the rabbits off the island of Leros, which they do. And the moral of the story is it is possible to have too much of a good thing. And they decided they would put one of the rabbits up in the sky to memorialize their being on the island of Leros. And that's how we get the constellation of Lepus there. Other than that, I'm not familiar with any other mythology surrounding Lepus. And if you want to know what Leros looks like, it's up there in the upper right-hand corner. It looks like a really nice place. I think I'd like to visit that sometime. Okay, the first object we're going to take a look at is Gamma Leporis, and this is a very lovely little double star. If you look at those 4 stars, well, first let me back up. There is the star Arneb, and that is a Arabic word which means hare. So in Latin, Lepus is hare, and Arabic, Arab or Arneb is rabbit or hare. But Arneb forms a corner there of a box-like structure. And then I guess towards the south east corner there is Gamma Leporis. Take a pair of binoculars and look at it. It is a very lovely double star. I've been working on the double star observing program here lately, and I've got about a quarter of them done. Oddly, I don't think Gamma Leporis was on that list, and I think it's such an easy target that they didn't include it. It's my guess. I don't know. But anyway, take a gander at it sometime when you're out. It is a very pretty, widely separated double star. M79, there is this one Messier object, Messier 79, and it is winter's brightest globular cluster. In fact, I think it's winter's only globular cluster. You'd be hard pressed to find any others this time of the year. Most of our globular clusters are seen during the summer, and they usually, as most of you know, hang out around the halo, the fringes of our galaxy. But this one is a wintertime object. It's not actually very good to look at through binoculars. I mean, I've done it before. It's usually just shows up as a very faint, fuzzy smudge, and not much detail to it at all. Even a pair magnified 7 times will make this cluster pop out. But like I said, it's just going to be a very faint smudge. So to be honest, you are going to have a large telescope to get the most out of it. And I've included a little picture there in the upper left, which shows what M79 looks like in a 10-inch Dobsonian. And there you can start to begin to see stars right towards the center of the cluster. You can find it by drawing a line between Arneb and Nihal, which is a star that makes up I think it's the beta star in Lepus, and it makes up the lower right-hand corner of that bowl or cup-like structure that is in the constellation there. Just draw a line between Arneb and Nihal, extend it the same length down, and you'll come to this 5th magnitude star. Just look to the east of that star, that 5th magnitude star, and there you'll find Messier 79. A nice little globular cluster, best seen in large aperture scopes. And let's see, we're going back. I don't know why. There we go. And I saved the best for last, R. Lepus. It is a carbon star. And the first time that I saw this star was at the River Ridge Observatory many years ago. I forgot who even had it in their scope. But it was a deep, dark red. It looked like, and the star is also called Hind's Crimson Star. There was a British astronomer named Hind who discovered it, as a matter of fact, and he described it as a pinprick of crimson, like blood, against a black backdrop. And that is exactly what it looked like. It looked like a drop of blood against a sea of black. It was the most beautiful thing I've ever seen, and I remember it to this day. I've tried to go back and look at it since then, and whenever I do, it's usually like a pale orange or coppery color. Now, R. Lepus is a variable star. It's a Mira variable, and it undergoes a cyclic a period in its brightness and dimming of about 14 months or so. But when it's at its darkest, that's when it looks the deepest red. So what's happening here is that with carbon stars, it has gone off the main sequence, and it is now a red giant. And it's began fusing hydrogen into helium. It has fused all of its hydrogen into helium, and the helium is now being fused into carbon. And the carbon starts to rise up in convection currents and carried to the surface of the star. And once it gets up there, this ash layer of carbon blocks out the bluer portions of the star's light. Now, the star is already radiating mostly in the red. It is a red giant after all, but there is still blue components to its brightness or to its color or to its light. But that blue component gets scattered out when it hits the carbon, and it only allows the redder portions of the star's light to reach our eyes. And it shows up as this deep, dark crimson red, like I said, whenever the star is at its dimmest. And I think it goes from brightness to a brightness level of 0.6 or 7, and can be as dim as 0.11. If you want to know what it's doing right now, go to the AAVSO, the American Association of Variable Star Observers, and you can look it up. And right now, at least as of yesterday, it was at a magnitude of 8.4. So that's probably going to put it pretty close to that nice, deep, dark crimson red color that I've told you about. So the next clear night that we get, if you get an opportunity, go out and see if you can find R. Lepus. It is worth your while. It is one of those beautiful carbon stars I've ever seen. So anyway, that is the end of my talk, and I will now turn it over to Darcy. Thank you. And I'm going to mute myself.
Daryl, thank you. That's a nice story about Lepus. I'm going to share my screen. It says I cannot share screen while the other participant is sharing. So, Daryl, will you unshare?
Yeah, Bruce, do I have to do that, or do you do that? You're muted, Bruce.
Yeah, you should be able to do it yourself.
You do it yourself.
Okay.
Unshare.
Let's see. Or new share?
No, unshare.
Or stop
should be a
share.
red button. Stop share. Yeah, it should be a red button somewhere. Should be at the top of your screen, I think.
There it is. Okay.
Okay.
Did that do it for you, Darcy?
Yes, it
You're
did.
gone.
Okay.
Yes, it did, Daryl. Thank you. I did enjoy your story of the hair in the sky. We are going to talk about the namesake of the Hubble Space Telescope. It's Edwin Hubble. He was an American astronomer. Are y'all seeing this okay?
Yes, ma'am.
Okay.
Yeah, it looks good.
My camera has cut out a couple of times. Let me know if something happens and I will fix it. Now, what made him important was that in the 1920s, his observations changed the way the astronomers were thinking about the universe. And I could tell you just about him, but this story is a whole lot better when it connects with the people and the places that he worked. So I'm going to be telling you little side stories along the way. He was born in 1889 in the little town of Marshfield, Missouri, and that makes him almost our neighbor. Well, this picture was taken at his grandfather's house. And his grandfather had a farm in Marshfield, and young Edwin liked the outdoor life on the farm. He loved animals, and he loved looking at the stars. And his grandfather was a stargazer, and he had a telescope in his garden. And it was a special treat when his grandfather let him stay up late and look through the telescope. And if you're ready for a road trip, Marshfield is a little ways north of Springfield, Missouri, on the old historic Route 66 highway. The Route 66 goes through Marshfield, and there it becomes West Hubble Drive. And in this little town of Marshfield, you can see the statue of the Hubble Space Telescope. It's a landmark on Google Maps. They're saying that Edwin was a bright student in school. Some of his teachers said he kind of had an attitude problem. But he was a good student, except for spelling, and his spelling mistakes followed him all his life. And he was good at sports. And when he was about age 10, that'd be about the turn of the century, the family moved to the outskirts of Chicago in Wheaton, Illinois. And here's the school that's been named for him. Here is Chicago at the turn of the century. It was the largest city in the Midwest. Everything had been rebuilt after the Great Fire of 1871. It had jobs and factories and construction and skyscrapers, railroads, fast transportation, rich people, and the University of Chicago. Well, the University of Chicago was founded in 1889, which happened to be the same year Edwin Hubble was born. And there at the university, they had enormous philanthropic gifts by Standard Oil Company millionaire John D. Rockefeller and other donors. And that afforded the school the most distinguished research faculty and facilities available. In 1906, Edwin and Hubble enrolled in the University of Chicago. Although Edwin wanted to study astronomy, his father, a businessman, insisted Edwin become a lawyer. And to please his father, he agreed to study law, but he also took classes in math, physics, and astronomy. Being over 6 feet tall and of athletic build, he played sports with some of the university teams. And while at the University of Chicago, Hubble applied for a Rhodes Scholarship and was one of the 2 students selected from the state of Illinois to go to Oxford University. And we're going to pause talking about Edwin for a moment, and I'll tell you some of the connections to the University of Chicago. Shortly after the university was founded, the first president of the university started planning a prestigious astronomy program. Astronomy was becoming popular with both amateurs and academics. And it turns out a young man named George Ellery Hale had been born into a wealthy Chicago family, and early in his life he found science to be his calling. George built his own observatory in his father's backyard and acquired his own professional long-focus refractor and spectroscopic apparatus competitive to what most colleges had. The president of the University of Chicago heard about this young, recent MIT graduate, Dr. George Hale, and he invited Hale to be an associate professor of astrophysics in the astronomy program of the University of Chicago. And by the way, he could bring his personal backyard observatory instruments with him. In 1892, these 2 men planned what would become Yerkes Observatory. The 40-inch refractor telescope at Yerkes is the largest refracting telescope ever built for astronomical research. It's got a 40-inch lens. Hale led the planning of the new observatory. It was financed by Chicago mass transit magnate Charles Tyson Yerkes. So now you know where the name came from. And this facility is sometimes called the birthplace of modern astrophysics. And this telescope was the first world's largest telescope that Hale built. And in 1904, he headed off to Mount Wilson Observatory. And I'm going to be showing you a few pictures of the Mount Wilson Observatory because the big telescopes are the ones that Edwin Hubble would soon be using. And it's a fascinating history. It really is. And here's the frame of the 60-inch telescope being hauled up the trail. They found out that 1 man and 4 mules could do better than a truck in getting up this narrow roadway. And this telescope, the 60-inch one, was the second world's largest telescope that Hale would build. Hale was a genius in getting the right people around him. He had the backing of John D. Hooker, who was a local California hardware businessman, Andrew Carnegie, and John D. Rockefeller. And after the Solar Tower Observatory and the 60-inch reflector, Hale started planning the 100-inch Hooker reflector telescope for his 3rd world largest telescope, and would go on to start the 200-inch telescope at Mount Palomar. So he built the world's largest telescope 4 times. I just love this guy, and I want to give another talk on him and all his telescopes. But as construction at the Mount Wilson observatories was going on, Edwin Hubble was enjoying life overseas at the University of Oxford and earned a BA in jurisprudence. The Rhodes Scholarship allowed him to study in England and explore European culture. He made friends with many wealthy British students, and he really liked this life that they introduced him to. Wealth and social standing became very important to him, and he was enamored with all things British. He wore tweed jackets and baggy pants and began speaking with a British accent. As he was finishing school there, he received word his father passed away. Then he thought again about becoming an astronomer. In the late summer of 1914, Hubble went back to the University of Chicago, and one of his former professors recommended him for a job at Yerkes. Hubble worked as an assistant to the senior astronomers, and he learned useful skills here. He also attended university classes and lectures and began a research project on his own. He chose to study nebulae, the fuzzy places in the sky. Classes at Yerkes included astronomical spectroscopy, that's splitting light into its component colors, and celestial photometry, which is measuring the brightness of stellar radiation. And in this time frame, 1914, the leading expert on nebulae was Vesto Slipher of the Lowell Observatory in Arizona. Hubble attended a scientific meeting where Slipher spoke on using spectroscopy to analyze light from distant nebulae. Some of the light was redshifted, meaning the nebulae were moving away from Earth. And for the next 2 years at Yerkes, Hubble continued photographing nebulae, identifying known ones and finding new ones. He measured and cataloged them. And this picture is part of the Milky Way. Hubble's work was noticed, and in 1916, he was offered a job by George Hale at his now famous Mount Wilson Observatory in Pasadena, California. Hubble hastily completed his graduate studies, but before he could accept the new job, the United States entered World War I. Hubble volunteered in 1917, spending 2 years in the service. Hale told him he would keep his job open while he was off in the service. And then other astronomers began working with this new 60-inch telescope. They were making important discoveries with it, including Harlow Shapley found that our sun is not in the center of the Milky Way. The 60-inch telescope opened the field of study of the spiral nebula, and programs included photography, parallax measurement, and stellar spectroscopy. And back east, Harvard Observatory astronomer Henrietta Swan Leavitt was studying stars called Cepheid variables. She discovered the brightness of the stars was linked to the time it took to vary in brightness. Her important work would help Hubble and others to develop their own theories about the universe. Henrietta Swan was among a group of people, women, that Harvard hired. It's kind of like the mathematicians that NASA had in the movie Hidden Figures, but that gets into a different story. So here's the pioneers who started out at the Mount Wilson Observatory. George Hale himself was a solar astronomer. He discovered sunspots were magnetic fields. And these men came to Mount Wilson before Hubble. You will recognize some of the names, especially Harlow Shapley here. As Hubble was finishing up school at Yerkes, Harlow Shapley had used Leavitt's discovery about the Cepheid variables to work out a reliable way of measuring distance in space. He calculated the width of our Milky Way to be 300,000 light years across, but not all astronomers agreed with him. After the war, there was a second wave of astronomers to join the Mount Wilson staff, and I have to say that scientists famously have big egos, and conflicts of personalities happen. Rivalries and jealousies were inevitable. Harlow Shapley in particular clashed with Hubble. Shapley called him Rubble instead of Hubble and mocked him for his British mannerisms and dress. But personalities aside, the 1920s became a decade for rapidly increasing understanding of galaxies. And I'm just going to mention the later group of astronomers who came on board, which included Fritz Zwicky, who Joe talked about in January. Zwicky was quite the character and apparently insulted everyone he ever worked with. But back to 1920, the great debate. Is the Milky Way the entire universe, or is it part of something bigger? This was actually a debate that they held at the National Academy of Sciences. So here we see Edwin Hubble at the 100-inch telescope at Mount Wilson. And we're going to take a moment and think what it was like to work at a telescope like this one. Notice the platform they are sitting on. It looks kind of like a musical instrument. It looks like you ought to be able to blow air into it and get music out of it. But here, the platform's been lowered down. You'll see what it is. It's a sawed-off chair that they have attached on the platform. The astronomer would sit on this platform and be raised to the correct height when he was doing his observations and guiding the telescope. The night assistant would control the movement of the dome and the astronomer's platform. Emily Levitt, in her book, The Last Stargazers, described the difficulties of being an astronomer at this kind of telescope. Generally, they would spend freezing cold mountaintop nights, now y'all know about that, in total darkness, working by feel, suspended in the dome on a platform, tracking the guide star of the telescope for long exposure of the glass photographic plate. Sometimes the tears of their eyes would freeze their eyelashes to the eyepiece, or static electricity would arc to their eyeball. It was really an endurance for hours-long exposures. But as they persisted, their hard work yielded much data and many discoveries, and Hubble made his biggest he made his biggest discovery at this telescope. This glass plate was Hubble's image of the Andromeda Galaxy, was taken in October of 1923. It was a 45-minute exposure. And he compared this plate to previous images on other plates. He was looking for nova, marking the letter N on the plates for novas. And he noticed one N was on top of another star. That was his aha moment. And he realized that he had discovered a variable star. And you see the scratched out N and exclamatory VAR written at the top of the plate. The next step was to use the variable star to work out how far Andromeda was from Earth. The result, 700,000 light years, surprised him and everyone else. Since Shapley had earlier calculated the width of the Milky Way at 300,000 light years, here was the answer.
Darcy, you still there?
I think we've lost her.
Darcy? We've lost Darcy.
Well, Bruce, do you have any jokes to tell?
Here, Darcy's coming back.
Okay.
Darcy, you back with us now?
Bruce, my computer says a problem happened and I have to restart it, so I'm going on to my iPad and I'll get my computer. Y'all take a break a second and I'll bring back the slides.
Doris,
Okay.
I was worried you maybe a black hole or something got a hold of you, but
Yeah, that must have been
back.
what it was. Aliens. Have you
Yeah,
read that
must-
book, Bruce?
No, I haven't.
I've got a copy of that. It's while we're on the topic of books. You mentioned the Stargazers, Darcy.
Yeah, Emily Levitt.
Yeah, that's a great book. But there's another one out about this whole thing that you're talking about, called "The Day We Found the Universe."
Uh-huh.
It's very, very good, and I highly recommend that to anyone who wants to learn a bit more about that period. I can't remember the author's name right now. It'll come to me here in just a minute. But Emily Bostiak, I think is her name. But anyway, check it out. It's a great book.
I think it's interesting that Hubble's father wanted him to be a lawyer. That was also the case with Tycho Brahe, who sort of launched modern astronomy. His dad sent him off to become a lawyer, and he just persisted in studying astronomy, even while he was studying to be a lawyer, and then ended up being an astronomer, of course.
I've been to Marshville, Missouri, to that telescope. I think Hubble's dad was the druggist in town for the town drugstore.
Pharmacist.
Darcy can probably fill us in if that's true.
I don't know. I had a screen message that I don't understand on my iPad.
What's it say, Darcy?
It says screen broadcast resume, and it has a microphone picture
Yeah,
on
well,
it.
we're seeing your screen.
Yep, we got your screen.
Yeah, you just
All
need
I
to
have is a
slides up
white
on it. Well, that's what we've got. We've got a white screen
There.
with a. There you
There we
go.
go.
Now we got it.
You have that? Okay, well, we'll do it this way then. Okay,
You left off at 35, I think.
yeah. I apologize. It's a new
Darcy,
computer.
Did
Sir?
you mention, I'm sorry, did you mention that Hubble was also a basketball coach for a while?
He did that when he was living in, I believe, Kentucky after he got back to school. And he worked as a law clerk. He was a boxer. He did a whole lot of stuff. But
Amazing man.
yeah, the cosmic ego really is a thing for him. Let's see, 30.
Yeah, it seems like all the
Oh.
great ones seem to have an ego
Yeah.
issue there.
They do. They do. Okay. 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 He had just found his glass plate and with the variable star on it, and Hubble's discovery proved the universe was bigger than the Milky Way. Now he couldn't wait to publish his discovery in the Science Journal. He
bet.
published his findings. Get a load of this. Findings in the New York Times in November 1924 and presented them at the January 1925 meeting of the American Astronomical Society. It was 4 years later when it was published in a peer-reviewed journal. So Hubble's discovery was soon linked to Einstein's theory of relativity. Einstein had proposed the idea that the universe was expanding. Hubble realized his own observations could prove if Einstein's idea of the expanding universe was true. And now Hubble was famous. The fellow just to the left of the screen is Hubble's night assistant. And we're going to mention him here. I love this guy too. Okay, Hubble teamed up with Milton Humason and confirmed nebula were moving away from Earth. And this finding, when it's run backwards in time, led a few decades later to the Big Bang Theory. From 1925 on, Hubble and Humason worked on how fast and far the nebulae were moving away from Earth. Humason was an expert on photographing the spectra of nebula, and that's important. I want to read you an endearing side story about Hubble's assistant, which also explains the research that they did together. The story is titled How a Janitor at the Mount Wilson Observatory Measured the Size of the Universe, from the 1 Minute Astronomer. Here at 1 Minute Astronomer, we always have a soft spot for the underdog astronomer, someone who overcomes circumstance to make great astronomical discoveries with skill and curiosity and raw enthusiasm. Milton Humason was born in Dodge Center, Minnesota in 1891. When he was 14 years old, his parents sent him to a summer camp on Mount Wilson near Los Angeles. The mountains, forests, and soaring views of Southern California stole the heart of the prairie boy. He convinced his parents to let him take a year off school to stay on the mountain and find work. But he never returned to school. Instead, Humason took up work as a mule driver, hauling lumber up a trail from the Sierra Madre to Mount Wilson to build the newest astronomical observatory, an enormous project organized by the astronomy pioneer George Hale. In 1911, Humason's heart was stolen once more. he became engaged to Helen Dowd, the daughter of the chief engineer of the observatory on Mount Wilson. They married shortly after. He left to work as a foreman on a ranch in nearby Laverne, but he missed the mountain. In 1917, Humason saw his chance to return and impress his father-in-law. He took a position as observatory janitor. This was a big step up from his mule driver and ranch hand. Soon after, the new observatory posted a position for night assistant, which is essentially a helper for astronomers who need to operate the telescope and observatory dome. Humason took up the role. His patience and skill and diligence brought him to the attention of Hale himself. In 1919, in the face of stern protests, Hale appointed Humason, a high school dropout, to the scientific staff of the observatory. Humason remained in this role until 1954. Humason worked with Hubble and later Hubble's protege, Alan Sandage, to study the spectral redshift of hundreds of galaxies to determine how fast they were receding, their so-called radial velocity. Hubble correctly believed the radial velocity of a galaxy was related to its distance, a relationship now known as Hubble's law. But these faraway galaxies had low surface brightness and were notoriously hard to measure. So Humason developed techniques to optimize the photographic exposures and plate measurements. He determined the radial velocities of 620 galaxies and helped set the distance, scale, and age of the universe. Much of Hubble's success was attributed to Humason's painstaking measurements. For his achievements, Humason was awarded an honorary doctorate from the University of Lund, Sweden. And this story was written by Brian Ventrudo as the 1 Minute Astronomer. I love stories like that. Okay, here is what Hubble is famous for. He worked out the mathematical way to describe his findings in Hubble's law. And he also devised a classification system of galaxies known commonly as Hubble's tuning fork. And I couldn't find out a whole lot of what he did after he made his big discoveries. Apparently he spent a lot of time traveling, vacationing, touring, lecturing in Europe. And people back home at the office were kind of grumbling that he wasn't there to help out. But anyway, in 1949, Hubble made the first photograph through the new 200-inch Hale telescope. It had been under construction for 21 years. And this telescope, you can see Hubble sitting there at the prime focus, was a triumph of innovation, insight, persistence, and precision, and would hold the world record for largest telescope for 93 years. Hubble won many prestigious awards during his lifetime, but he never won the coveted Nobel Prize. And the problem was simply, at that time, there was no category for astronomy and Nobel Prize selections. He had married into a wealthy California family. They traveled extensively and entertained friends in lavish style. About 6 months after first using the big 200-inch telescope, he suffered a heart attack while he was on vacation in Colorado. His wife cared for him while he was on a modified work schedule until he died, and that was in 1953. He was 63 years old. In 1990, NASA launched the first space telescope. It was named the Hubble Space Telescope in honor of the work Edwin Hubble did. And here we see a composite of Hubble's own photo and the Hubble Space Telescope's photo of the same area. And what's really neat is Edwin Hubble's career began because as a kid, he liked to look at the stars. And I have to ask you, if you have a story about looking at the stars when you were a kid, please share it on our listserv. we've gotten some really good stories from our people. We need more because it's very heartwarming. It makes all of us feel good, and we have a shared background that we can relate with. If you found these telescopes fascinating, you'll be interested to know that the 60-inch and the 100-inch telescopes are now retired from active scientific service. However, the two telescopes are the largest in the world made exclusively available to the public. You can tour them or rent them for a night of observing. And the same for the 100-inch. And to reserve the telescopes, all you have to do is contact Mount Wilson Observatory and write them a big check. And I want to say thank you, and I've enjoyed telling you this story. And when I get my computer restarted again, my other one, I'll be back and I'll see you on the back side of the meeting. So thank you.
Thank you.
Yeah, thank you. That was
Great presentation.
Anyone have any questions or
Very
comments?
nice. Thank you, Darcy.
Anyone have any questions for Darcy?
Yeah, are Darcy still there?
I'm still.
Darcy, I just
And,
wanted to ask you, if we put a CMOS, can we put a CMOS camera on one of those telescopes if we rent it?
For that price, you should be able to put anything you want to put on it.
We could have a star party.
We could rent a bus and all go out there and have a nice show.
I've been to Mount Palomar. It's a great place.
Great presentation. Both of
Yeah,
them.
Darcy, I was especially interested when you were kind of talking about kind of the physical, how physically hard that was back in the day, of observing, something I really didn't think about. But I mean, when you're sitting there and you're telling us that, where the tears are freezing to their eyes, it kind of just makes you think, it's in a way how, easier we had it. I mean, we can flip on a computer and get our image and everything. But man, those guys, that was pretty intense,
Yes, and up to 8 hours exposures on some of those. And well, you know that they would take a thermos full of hot coffee, and then after they drank the coffee, well, you have to use your imagination on what they did with the thermos afterwards, because the humanitarian facilities were just not there for everything they needed. So, and that's what Emily Levesque's book was essentially keyed upon, is that these people were looking at the stars through the telescopes. And today's astronomers sit at a computer and guide the telescope, run their programs, and get a printout of pictures and data or squiggly lines. And that marked the end of the last stargazers when the technology changed.
I was talking to some of the grad students at ULR a few years back, and they were complaining that they had never had the opportunity, and all the courses they had taken at ULR in astronomy, they had never had the opportunity to look through a telescope. Some of them, in fact, had never looked through a telescope.
The big difference between film and analog and now going to digital, if you looked at the pictures of Andromeda that Hubble took on the plates, that's analog compared to the digital image from the satellite, which everyone's used to now, where you just assign colors to all the different photons you're capturing.
Well, look,
Bruce,
I'm
have
still
you
old enough to, I was going to say, I'm still old enough. When I was first doing astronomy photography, I had my 35mm camera on my 6-inch f8 with a guide scope, and I'd be out there some images anywhere from 2 to 6 hours.
I only stopped doing film about 8 years ago.
Darcy, you had a question?
I hope you have unshared my screen, because I can't stop it from this end. I'm just going to have to.
Well, we're not seeing your screen.
We see you.
Okay. Well, I can't see me, and all I can see is a blurry thing with a message on it that I can't get rid of.
Well,
So
don't worry about it.
technical difficulties, but I will be back.
Okay. Great
Thank you again,
presentation.
Darcy.
Yep.
Does anyone have anything else they want to talk about or to mention?
Well, actually, I did have a question on, is it Lepus? Is that correct? Am I pronouncing it right?
Yeah, that's right.
Yeah. Is it like, like Orion, you can only be seen certain times a year. Is it the same in that constellation? Are
Right.
there
Yeah.
like times?
Yeah, it's mainly a wintertime constellation, and we are now coming towards the end of its season. So by April or so, it'll be disappearing below the western horizon right around sunset. So now is a good
Okay.
time to get out and look at it while you can.
And
Well,
of
one
course,
the
it's
things
been pursued by Canis Major
Right.
and Canis Minor.
Well, one of the things I wanted to mention, we were talking back and forth, some of us, about Messier marathons or doing something with Messier observing objects. And I was talking with Jim Dixon, and we were throwing around the idea that maybe between now and the end of April, we could have some Zoom presentations where somebody would, I don't think we'll be able to go through all 109 or 10 objects, but make a Zoom presentation of some of the things using photographs that were taken by people in our club, so that you can see that, hey, this is something I could attain if I get into astrophotography. So don't use stuff from the Hubble. If you ever see some of those pictures, they're so almost outlandish. But to use pictures that our club members have taken, people can donate them in and present them, and then talk a little bit about the objects, where they are, what they might even look like with the eye versus the camera. And then people could get an idea and appreciation. So sort of a sense, do a virtual Messier mini marathon. I don't know if people would be interested in attending such presentations.
That sounds like fun.
Yeah, that sounds kind of cool, actually. Yeah.
I love your background, Joe,
Oh, thanks.
on the Starship Enterprise.
Yeah, Star Trek nerd. So
Big fan too. So I was thinking one of the people that could either Jim took some images. He said he'd be willing to do the first one, or I don't know if Rocky wanted to launch it by giving a first thing about history about Messier and what was going on. So something like that. Let's try and get it started. And if anyone's really interested in making a presentation for that, just email me and I'll start to organize it.
Well, a good topic for the April meeting would be on Charles Messier.
Possibly, yes.
If Catherine can get a volunteer.
I did one of my night sky episodes on Charles Messier. It's still up on YouTube. If you get a chance, you can find it over there. Hooray for Mr. Messier, I think is the name of it.
This is John Reed. Could I share the screen for just a second? I have something I want to show.
Sure.
This is the Milky Way I took, and I was going to show you.
wow.
Lepus is right down here. This is Orion, of course. That's Bernard's Loop. And they call that the head of Orion. It's a very faint nebula.
Wouldn't it be a little further to the right on the bottom there?
Lepus?
Yeah.
It's pretty much right underneath Orion. Right down in there. There's Sirius, see?
Right. Yeah, I didn't think it was that far over to the east from the Orion Nebula, though. I thought it was more like down below, in between Rigel.
No, those stars right there are part of Lepus.
You just need to turn the picture in your head, Daryl. That's what's throwing you.
Well, where is Rigel?
Yeah.
Just turn the picture counterclockwise in your head. It's
well,
right
Rigel
it's pretty
is,
much under.
isn't that Rigel?
Yes.
Okay.
Can you see
All right.
my cursor?
Yeah. Okay. I see you now.
And then there's the rosette up there. And then this goes all the way up to that's the California Nebula up there in Perseus. But anyway, and this was taken all with the narrowband filter, so all the H2 regions show up. Anyway, I thought you might want to
That's pretty cool.
kind of see where that is. Let me stop sharing. Okay, here we go.
Well, unless
Thank
anyone
you,
has
John.
anything, unless anyone has anything else they want to add or say, I guess we're done until next time.
Thanks.
Yep, great presentations tonight. Thanks.
Yeah, fantastic.
Yeah. Oh, hey, and
Good,
Bruce,
good.
again, thanks for helping out there on the hosting this thing.
Sure,
So,
anytime. We had
yeah.
a nice attendance tonight.
Yeah.
Got up to 25, I think.
Good.
So
Well,
Joe, where are you
signing off.
taking the Starship next?
Yeah. I haven't decided yet. I'll have to ask the crew.
I'm going to sign off. I hope all of you have a good weekend. And
All right, thanks, Daryl.
Thank you,
Oh
Daryl.
yeah. Oh, and I know y'all probably heard this 100 times, but it's the dreaded springing forward. So, you know, what is it, 2 a.m. tomorrow morning or
Yeah.
officially or something? So.
And Joseph, you're wearing a red shirt.
Oh.
Oh yeah. So nice knowing you guys.
I always get killed.
Just saying.
Yeah. So I give myself another 10 minutes and something's gonna happen. You know how it goes.
Goodbye, everyone.
Good night.
Yeah.
Good night.
Not.